All right, let's have a look at calculating. Let's have a look at calculating the volume of these prisms. I'm going to give some measurements to this left-hand side and the measurements to the right-hand side, and maybe you can just give it a try if you want first before I go through it. So let's use a calculator and a bit of, let's make this 20 meters over here. This is 5 meters over here and 6 meters over there, which is my depth. Here I've got a perpendicular height of 8 meters, a base of 20 meters. The upper part of this will be 10 meters, and the length of this is 15 meters. All right, so whenever we calculate the volume, all we have to do is the following. But if you want to first give it a try, give it a try first. Let's call this one question 1 and question 2. All right. Now, the first thing I'm going to do is look at this rectangle over here. And I'm going to find that rectangle's area. All right. So the area of the rectangle is given by length times width. Now let's pick out the length. You can see that is the length because it's how long it is. And that is the width. The 6 has no play inside the area of this rectangle. So we take 20 and we multiply it by 5. And 20 times 5 will come to 100 meters squared. Now the formula for volume says take the area and multiply it by the depth. So we take this area, which is known as the cross-sectional area because it's repeated all the way through, and multiply it by that number there, and that number is my depth. That is the number that makes my 2D shape into a 3D shape. It makes my rectangle into 3D because it moves 6 meters back. And so that'll be the depth over there, 6 meters. And now we're going to take 100 and multiply it by 6. So let's do that. So if I take 100 and I multiply it by 6 meters, it'll come to 600 meters squared. I mean, cubed. Because we got 100 meters squared and we're multiplying by m again, don't forget this has to be cubed. So area is in meters squared, volume is in meters cubed. The units is very important as well. Okay, question number 2. Here my cross-sectional area over here is going to be a trapezium. All right. That shape over there is a trapezium. And so the area of a trapezium is given by half A plus B times H. Now, what is A, what is B for this, you might say? Okay, so A equals 10, B equals 20, and H equals 8. And so this comes to a half of 20 plus 10, because remember that's A and B. I wrote it the other way around. It should be 10 plus 20. 10 is A, 20 is B. And you can see this bracket needs to be done first. So we're going to add this first. And the height is this dotted line, or the line that is vertical to the base, or 90 degrees to the base. So that's going to be 8. Now this is multiplied as well. So 10 plus 20 is 30. And half of 30 times 8, you can put this in the calculator. You could even half the 8, it'll become 4. And 4 times 3 is 12, and put a 0. So 120 meters squared would come to this. You could also go half of 30 is 15, and 15 times 8 is 120. Now remember, volume will follow the same formula, area times depth. So volume is going to be equal to this area multiplied by this number, the one we didn't use yet, and that's my depth. So it's area times depth. Now what's my area? 120. And what's my depth? 15. All right, let's calculate 120 times 15. If I don't have a calculator, how do I do this? Let's see if I could possibly calculate it over here. 120 multiplied by 15 is the same as 120 multiplied by 10 plus 5, because that's 15, right? Take the 120 multiplied by the 10, it's 1,200, then multiplied by half of it. And what's half of 1,200? 600. And then add it up. It comes to 1,800. And so this will be 1,800 meters to the power of 3, because remember, volume is meters cubed. Your units will serve as an extra mark. All right, so it's important to make sure that you get your units perfectly. All right, and that's it.